Greetings, fellow nerds. Let's talk about the derivative of arctangent. So this is an inverse function. Let's actually use that formula that we used previously on another video with regards to differentiating inverse functions. So that being said, yes, you do want to know the derivative of a general inverse function. I think that's healthy. Pythagorean identities are going to come up in this as well. But outside of that, this should be something you should be able to handle. So putting it all together, like I said, we're going to imagine the derivative of the inverse tangent. We're going to imagine inverse tangent, right? That's our inverse function. So we have this formula from a previous video. So do make sure you go find that video in this series. All right. So again, the tricky thing about this formula is reading this notation. So remember that what you see right here, this is the derivative. This derivative is the derivative of the inverse function of f. So whatever is written right here, its inverse function, its derivative is what goes right here. So that being said, if inverse tangent is our homie, well then what's the function that is the inverse to the inverse tangent? Well, that's just tangent. And so its derivative, which is secant squared, that's what goes right there. So now let's put it all together. Here we go. So the derivative of inverse tangent, we're going to use this formula. So let's just apply this formula. This is a general formula. Let's apply it. Right? So like we said, the derivative of the inverse function to arctangent is secant squared. So that's what goes right there. And so just replacing f prime with secant squared, we get this. Again, remember that inverse of f was something we said was arctangent. So let's just replace that right there, and we get that expression. Well, there's something really interesting and I think remarkable we're going to do, and that is, well, first off, secant squared, if you remember, is actually 1 plus tangent squared. So what I'm going to do is actually replace this secant squared with 1 plus tangent squared, which gets us to this formula. If you looked at this formula long enough, you might notice, again, there's something really cool here. This too, right? So remember that square actually means this whole thing is being squared. More specifically, it means this, which, again, if you thought about that long enough, what we have is arctan inside of tan. Well, those are inverse functions of each other. And so putting a function inside of its inverse, they undo each other, and thus we're just left with x. And so the derivative of the inverse tangent of x is actually 1 over 1 plus x squared. And as always, have a great day, nerds.